three-dimensional, it is a solid shape. A sphere can roll, is curved and it's not flat. Marbles, earth, and baseballs are some kinds of spheres. A sphere is three-dimensional, it is a solid shape.
Hey geometry students, so welcome to our final lesson in chapter 11 on spheres. We're looking for area, surface area, and volumes of spheres. And so it's going to be kind of similar to the one in the last lesson with the cones, but now the shape is more like a ball. So let's go ahead and look at a cartoon. And here's another Far Side cartoon. You're kidding! I was struck twice by lightning too. There's a big asteroids coming in to crush them, it looks like. So I've got a sphere on this far side. You can see the asteroids in the shape of a sphere coming from outer space. So these two guys are, probably the most unlucky guys of all. All right, let's go ahead and take a look at our finding surface area of spheres. A sphere is a set of all points in space equal distance from a given point, and this point is called the center of the sphere. So as you can see here on the diagram, center of the sphere is right in the middle of the ball or the sphere. A radius of the sphere is a segment from the center to a point on the sphere. So that's right over here, point on the sphere. There would be our radius. A chord of a sphere is a segment whose endpoints are on the sphere. So if we have a chord, we would have, one endpoint is on a sphere, the other endpoint also is. The one that matters though is the diameter. A diameter of a sphere is a chord that contains the center. So the diameter is like a chord, but again it goes through the center point, showing us that's the diameter of the sphere, which would be again twice of what the radius is. Then we have this thing called the great circle. You're doing this all on page 351 in your vocabulary. So basically a great circle, if you have a plane that cuts the sphere in two equal halves, it cuts it into two equal hemispheres. And so that's what this is kind of saying here, and you might want to write down, this is important, that the circumference of a great circle is the circumference of the sphere. So whatever this cross section here is, the circumference of that would be the actual circumference of what the sphere is. And then we want to make sure you understand hemispheres, that this cuts it into two congruent halves called hemispheres, and our Earth is the same way. The equator would be our hemisphere, cutting the Earth into two equal halves. All right, let's go ahead and take a look now. This is all kind of just understanding a sphere, and now we want to go to understanding how to find the surface area of spheres. And so there is a formula for that with 4 pi r squared. That's our formula for that, but where does that come from, or how do we understand that? And I think a baseball is the best way to understand that. It says to understand the formula for the surface area of a sphere, think of a baseball. The surface area of a baseball is sewn from two congruent shapes, each of which resembles two joined circles. That's what we have here. So here's these are two congruent shapes here. The entire covering of the baseball consists of 4 circles. And so that circle right here is actually the size of our great circle of this baseball. And you can see how that's a little bit bigger than where this stitching is. So you have the stitching out here. It's going to be a little bit greater because once you put in 4 circles there, you have circle here, another circle here, another circle in here. You're going to end up having just a little bit of extra space, maybe like right in the middle. So that's why these are a little bit bigger, the circles, the hemispheres here, the circumference then would be a little bit bigger than the side of these shapes. So that way when you put it all together, it makes the actual baseball. All right, so that would be our formula, 4 times pi r squared, because you're looking at the area of this one circle times 4 of them. Let's go ahead and try some now. Okay, so here we have the surface area, finding the surface area of the solid. So 1 and 2 are both spheres, and then 3 and 4 are actually hemispheres, half of the sphere. So let's go ahead and put down our formula again. This is on page 352, 4 times pi times r squared. They tell us the r. It's all we need to know is just plug the r into here. And so it's going to be 4 pi times 5 squared, which will be 25 times pi, or I should say, sorry, 25 times 4. And so that's going to end up being 100 times pi. So 4 times 25 is going to give us 100 pi, and then just 100 times pi on the calculator is 314 centimeters squared. And that's again approximate answer. So we're finding approximate answers here because obviously pi is going to be rounded. And then number 2, our diameter shows us 9, so we need to realize that the radius really is 4.5. That's what we're going to plug into our formula. So again, we're going to put as S for surface area, 4 times pi times r, which is 4.5 squared. 4.5 times itself is 20.25, and then 4 times 20.25 on the calculator gives us 81. So we have 81 times pi, and now when we multiply 81 times pi, we're going to end up getting approximately 254.34 inches squared. Notice I'm in square units because we are talking about area, again, surface area. So these are all going to be in square units. And then for the hemisphere, basically the only thing we need to do for this, it's going to be half of this formula here. So what we can do is, instead of 4 times pi times r squared, it's really going to be 2. So if I divided this formula by 2, then I would actually divide 4 by 2 and just get 2. So our radius is 1 because it shows us the diameter. So the radius is 1. So we want to see that for the hemisphere, it's going to be 2 times pi times r squared. And so it's just going to be 1 inside there for the r. So 1 squared is still 1. That really is just going to be 2 pi. And 2 times pi is 6.28, approximately 6.28 feet squared. And then for this other hemisphere, we're just going to see that's 11.2 is our radius. We're just going to plug that into the same formula that we have over here, 2 pi r squared. And so it's going to be 11.2 squared. So on the calculator, what that will equal is 125.44. This is actually a 44 here. So 125.44. Let me just double check that. So 11.2 squared. Yeah, 44. So 125.44, and then 2 times that number. So if I just multiply by 2, so times it by 2, that gives me 250.88. So it's going to be 250.88 times pi. So when I multiply this now times pi times the 3.14, that's going to be approximately now a number here of 787.76 if we go to 2 decimal places. So there's your answer. Approximately 787.76 meters squared. All right, so that's finding the surface area, which is not hard to do once you just know your formula and use your formula. All right, we're going to move on to volumes next. Okay, so as we start to get into volume, I wanted to go back to page 350 in your notes and look at these two right here. It says here, a cylinder is circumscribed about a sphere as shown. So you got the cylinder, and then the sphere is inside the cylinder. It says write a formula for the volume V of the cylinder in terms of the radius r. So it gives us, remember for the cylinder, it's always base area times height. And remember that's what we see here. So we can see, okay, for volume of a cylinder, it would be pi r squared times the height. That's for the cylinder. So if we're going to say, okay, well my radius is r, so that's just r right there, but the height is really 2r. So when I plug in the height, which is 2r, right here, it's going to be, we're going to say actually it'll look like pi r squared times times 2r. I'll get rid of that. So times 2r is our height. And so now what we're going to see for this, when we say r times this r, it's r cubed. So we'll put the 2 up in front, and then pi, and then r to the 3rd power. So that would be the volume of the cylinder with the 2r being the height. Then it says, okay, when half of a sphere, which is a hemisphere, like this right here, is filled with sand and poured into a cylinder, it takes 3 hemispheres to fill the cylinder. So 3 of these. So you got, basically one going right here, and then another one, right here. So each one, so that fills, one of these fills it 1/3 of the way, 2 of them is going to fill it 2/3 of the way, and then 3 of them will fill the whole thing. Well, we need to realize that a hemisphere is half of a sphere, like half of the sphere, or we can think of a sphere is 2 hemispheres. So basically what we're looking at is we're seeing it's going to fill it up, so it fills this down here all the way up, but it fills this also. So that's 2/3 right here, 2/3 of the whole thing. So 2/3 of this whole formula for the hemisphere, or for the cylinder. So if I were to multiply this now, and I'll just do it over here, I'll simplify this down to where I had this. If I was to multiply this now times 2/3, I'm going to end up getting my formula for the volume of a sphere. So when I do this, it'll be like this is over 1. So when I multiply on the top, I'm going to get 4 up on top. So it's going to be basically 4 times pi times r to the 3rd power all over 3. Or they might also, they'll show it to you as, you could say this is 4/3 times pi r. So you could say also this 4/3 times pi r cubed. So either way is this formula. That's our formula. That's how we get the formula for the volume of a sphere. Alright, so that's what we're seeing here on our page 352. In the core concept, there's 4/3 pi r cubed. Now you know how we get this and why that's true is because it's 2/3, the volume of a sphere is 2/3 of the cylinder that would have its basically the same height, which the height of a sphere is 2 radiuses. Alright, let's go ahead and try just using that formula now for the volumes. Alright, now on page 353, to find the volume of the sphere. Number 5, it shows us 15 inches is the diameter, so half of that will be our radius. We need to know what the radius is for our formula here, 4/3 times pi r. So we just got to, again, fill in the radius. It's all we need for these spheres, which is, a pretty easy thing as long as we have our formula out. So it's going to be 7.5 for the radius here, so when we plug that into the formula, it's 4/3 times pi times the radius, 7.5 to the 3rd power. So we need to figure out, okay, what's 7.5 to the 3rd power? You can just use a regular calculator like this, or use a exponent, scientific one with an exponent button. But basically 7.5 times 7.5 times 7.5, 3 of them will end up giving us 421.87 or 0.88. And so that's what we're seeing here. So we got 4 pi times that 421.88 divided by 3. So I kind of think of this always, do all this on top and then divide it by 3, I think will be easiest. So if I multiply this now times 4, so multiply by 4, I'm going to get that number. That's what's going to be multiplied by pi. So we times this by pi now, 3.14. And now on the top of our fraction we see this number. So that's what's going to be here. See, there's our number, this times pi, which gives us this. And so then we get our, well, I showed you a little differently here. What I did is here, I divided this by 3 first, then times it by pi. It doesn't matter which way you go here. Here I multiplied it by pi, and then if I divide by 3, I get the answer of 1766.25, and that's what we're seeing here. 1766.25 inches cubed. Remember, we have cube units whenever we're trying to find volume. So there's more than one way you could do this. You could, like I did here, I divided the number by 3 and then multiplied by pi this way. Or on the calculator, I just showed you, I multiplied everything on top and then divided by 3 last, and I still got the same answer. All right, number 6, same thing here. Our 13 is the radius. We're just going to plug that in, 13 to the 3rd power. So 13 times 13 times 13, let's do it 3 times, not too long there, 2197. So that's going to be 4 times pi times 2197. I can multiply by 4 right now and get 8788. So I just took this right down to the answer there, didn't I? So there's 8788. I can multiply by pi, so times it by 3.14, and that equals this big number of 27,000, and then just divide by 3. And that will give me my answer of 9,198, and I went to 2 decimal places with 0.11, and it's centimeters cubed. So go ahead and stop the video and try 7 and 8 on your own, and then go ahead and play that to try to check your answers on 7 and 8. So do 7 and 8 and then play it again. Alright, hopefully you've already done 7 and 8, and you're just going to check to see if your answer is correct. For 7, we have our radius is 3.5, so 3.5 to the 3rd power is actually 42.88 on the calculator. When you multiply everything here, 4 times pi times this decimal, and divide it by 3, we're going to end up getting that answer. 179.5. So check to see if that was the answer you got with centimeters cubed. And then for number 8, 10 is the diameter, so 5 would have to be our radius. So when we plug it in, it's going to be 5 cubed, which is 125 right here. So it's going to be 4 times pi times 125 divided by 3. And so when you multiply all of that together, divide it by 3, our answer for this one is going to end up being 523.33 inches cubed. So again, check your answer to see that you got that correct. If you didn't get these correct, go back to check your calculator and try it again. Just 4 times 3.14 times 125. Figure out what that is on the top and then divide it by 3, and that should give you your number. Alright, so let's pause for our joke of the day. What do snowmen eat for breakfast? Ice Krispies. Alright, so in the extra practice, 9 through 11 says find the indicated measure. So we're not necessarily finding the sphere's surface area or volume. That's what's going to be given to us. We're trying to find these other things like the diameter. This one does, in the second one, says volume of sphere. On that one, given what the surface area is. And then volume of sphere, given the surface area again. So let's go ahead and try to first find the diameter on this one. If we're told that the surface area is 144 pi. So we're going to have to use the surface area formula, and we're looking for diameter. Surface area formula was at 4 times pi times r squared, and so 144 pi is actually what the s is over here. So that's going to get plugged in as 144 pi is equal to our formula, and then what we want to do is we want to solve for r. Because if we can figure out r, we can then just double r to find the diameter. So we have to divide by 4 pi first to get the r squared by itself. That's going to cancel our pi's out here. So 4 pi's cancel, r squared is by itself. 144 divided by 4, that's 36. And then to get rid of the square, just take the square root of both sides. So the square root of 36 is 6. That's what r equals. So if you just double 6, that's going to be 12. Your diameter is 12 centimeters. Because if we're in centimeters right there, it says, so we know we're going to put centimeters at the end. For finding the volume of a sphere with a surface area of 256 pi inches, or pi square inches, we need to find also the radius again. We need to know what the radius is so that we can plug it into the volume formula and find the volume. So doing the same thing here, we're going to use our surface area is 256 pi. It's equal to the 4 pi r squared, just like we did up here. Divide by 4 pi again, canceling out our pi's. 256 divided by 4 here, that's going to give us 64. Take the square root of both sides again to solve for r. The square root of 64 is an 8. So that tells us our radius is 8. So we can plug 8 into the volume formula, which we know here's our volume formula, 4/3 times pi times r cubed. So we got to do 8 cubed. So I do it over here. 8 times 8 times 8 again. That's 512. So we're going to see 512 going there. We're going to multiply. You can do just like we did on the last one, 4 times pi times 512 if you want to do it that way. Then divide by 3. That will work. So we can just do that on the calculator here. I already have 512 in the calculator, so I could just say I'm going to multiply it times pi. I can multiply by 4. It doesn't matter. So I say, okay, times 4 is going to give me that number times pi, 3.14. This is all what's on top, 6,430. And then we just divide by 3, and that will give us our volume then, 2,143 approximately. So actually, they left it in terms of pi, that's right. So I left it in terms of pi because that's the way the answer wanted it to be. Our surface area was in terms of pi, so they want the volume in terms of pi. So if I did that, that would have just been 512 times 4 divided by 3. I'm just doing the numbers, not actually multiplying by 3.14. So if I just did that, if I have my 512 back on the calculator, I'm going to times it by 4 and then just divide it by 3 from here. So divide by 3, that gives me 682.67, and then we put pi next to it. So good rule of thumb is if in your problem here, if it's left in terms of pi, they want you to leave your answer also in terms of pi. Go ahead and pause the video and try number 11. 11 is just like number 10, and see if you can do that one correctly. Okay, so hopefully you've tried number 11, and you should have left your answer again just like this in terms of pi. So we're going to just first find the radius. So if our surface area is 400 pi, it's going to be 400 pi. Oops, there we go. Actually, I didn't leave my answer in terms of pi, now did I? On this one, I left it. You can actually go either way. So there it is in the actual decimal answer. Over here, 400 pi is equal to 4 pi times r squared, just our surface area formula. Divide by 4 pi, and so that would end up giving us 400 divided by 4 is 100, and then we take the square root of that 100, so the radius is 10. Hopefully you got radius of 10 on this one, and then when you plug that in, it's going to be 10 to the third power, which is 1,000, and so that gives us these answers here. So we can say 1,000 times 4 divided by 3 giving us that number there, 1,333.33, just 3 keeps repeating, times pi can give us this answer. So there's our answer in terms of pi. Here's our answer actually just as the decimal answer with feet cubed. So you kind of want to see, which one is it going to be. If you're plugging it into the big ideas for the assignment and then you plug in this number and it tells you you're wrong, then maybe they wanted it in terms of pi. And so you can just write it in terms of pi. And I think that might be the way they want it in big ideas. All right, we have just one more to look at and do from a composite. So we've been doing composite ones, which is like two shapes in one. So here's a example of a composite. This is actually a cylinder, but missing out a hemisphere. So in this is like it's dug out, and so this part's missing here. So basically, you're going to be saying the cylinder minus the hemisphere is what you're seeing here. The volume of the solid is the cylinder minus the hemisphere. So we actually find the volume of the cylinder, that's the pi r squared times h, minus the hemisphere, which would actually be a half of this. So they're going to multiply a half times our sphere formula. And once they do that and plug everything in, they plug the radius in, plug the height in, and then they just simplify this whole thing down to our answer. There's the answer in terms of pi, and there's the answer with the actual decimal. We're going to try this one here on page 352. You can go ahead and copy this like ice cream cone here with an ice cream scoop on top. And so we have a cone, and then on top is a hemisphere. And it's just number 7 right there, so just go ahead and copy this. We're going to find the volume of this composite solid at the left, which is just number 7. Okay, so go ahead and write this on page 352, right there into the notes section. It's right underneath the volume core concept. So this would be our composite up here, and you're going to try to draw this, draw this as well. So kind of a cone, and then on top of a cone, a hemisphere. So basically to do this one, to find the volume of this, we'd have to find the volume of the cone and add that to finding the volume of the hemisphere. So we would do this here, the cone plus the hemisphere. So for the volume of the cone, remember this was the last lesson, was 1/3 times pi times radius squared times the height. So it's like the base area, so the area of the base here, which would be your pi r squared times the height, but because it's a cone, you got to multiply it by 1/3. And then we're going to add that to the formula for a hemisphere, which is just half of the sphere formula. So you're going to say 1/2 times 4/3 pi times the r cubed. So 4/3 pi r cubed, that's our formula for the volume of the sphere. We just got to multiply that by a half because a hemisphere is half of it. So we have to fill in just a couple things. Radius is going to go in both of these places. The height's going to go here. So we'll start by doing 1/3 times pi times the radius, which is 1 here, squared times the height, which is 5. And we're going to add that to 1/2 times 4/3 pi times 1 for the radius to the third power. So 1 cubed is still 1, 1 squared over here is still 1, so that will be easy enough. So we're going to see 1/3 times 5 pi really here. We're going to be multiplying it by 5 pi when we combine this together, when we get 1 times 5 times pi. So 1/3 times 5 pi, and it's going to be added to the 1/2, and inside here is just going to be 4/3 pi because this is just a 1. So it's just 4/3 pi there. So as we kind of multiply these together, we can think of this as over 1, and now it's just 5 pi over 3. 5 pi over 3, and it's going to be added to here. We can think of this also as pi could be up here with the 4, So if we think of it as 4/6, which we'd want to reduce that down to 2/3, so really 2 pi over 3. We can cross cancel 2 and 4 as well to get 2 pi over 3. And so if we needed to get the answer in terms of pi, we can just add these fractions together. They have a common denominator, so 5 pi plus 2 pi is 7 pi over 3. There's our answer in terms of pi. And then if we want to do this on the calculator now, so we would say, okay, 7, so 7 times 3.14, and that would equal 2198, and then divided by 3 is equal to 7.33 if we round it up to 2 decimal places. So our final answer there as a decimal would be 7.33 meters cubed. So there's our answer. Alright, so that concludes 11.8, and so now you're ready to go on to the assignment, and I'll see you soon.